Hello and welcome back to our Pipeline Survey Techniques mini-series. I'm Rachel Seeley-Fisher and today I'm joined with Neil Webb. Neil is an industry expert in corrosion and the cathodic protection sector. Today I'm hoping you'll help us understand combination surveys, and in particular the CIPS DCVG combination survey. Now, we've already covered CIPS and DCVG separately in previous videos, but for those who haven't watched them yet, could you briefly explain what they are?
Yes, well, it's very straightforward. The CIPS survey is a close interval potential survey. That's what the letters stand for. And what it means is that you walk over the pipeline route with a reference electrode that is connected to a data logger and a trailing cable, and you measure the potential of the pipe with respect to the soil at close intervals.
Makes sense.
Along the pipeline route. And typically that interval will be something close to the depth of cover of the pipeline. So if the pipeline is buried a meter and a half deep, then you take measurements literally at 1 meter spaces. And that tells you what the potential of the pipeline is. And then the DCVG survey, DCVG standing for direct current voltage gradient, it requires two sets of electrodes, and you measure the potential difference between two matched electrodes. And as you well know, if you've got a resistance and a current flowing, it develops a voltage, a potential, Ohm's law.
Right.
And so we measure that potential gradient. And that tells us information about the condition of the pipeline wrapping.
Perfect, thank you. What are the primary objectives of a combined DCVG CIPS survey?
Well, the CIPS survey is best known for telling you what the condition of the pipeline is in terms of cathodic protection.
Right.
So is the pipeline protected or not by the cathodic protection system? And the DCVG survey, its primary function is to show you whether you have defects in the coating or wrapping system. They could be mechanical defects that were caused during laying of the pipeline. It could be caused by degradation of the wrapping over time. It could be caused by roots penetrating the pipeline coating, for example. Some of the old pipeline coatings, like bitumen, for example, the roots are susceptible to damage. This damage then exposes the steel of the pipeline. So the DCVG tells you you've got a damage, and the CIPS tells you whether that is protected or not. And the two are completely different. So you can have coating defects, but still have an operational cathodic protection system, which means that your pipeline is not corroding. So it's not a high-risk situation.
Right. So this combined survey kills two birds with one stone.
Yes.
Perfect. Now, how does the data from a combined survey help your pipeline operators assess the coating condition and the cathodic protection effectiveness at once?
Well, the data analysis is done after the survey.
Okay.
So you go over the pipeline route, you gather all the data, go back to the office, and you post-process. And that data is then linked to the position of the survey team, where it was. And you can tell from that data a number of different things. So it tells you the extent and the severity of a defect. We call it a defect indication.
Okay.
Because actually you don't know that it's a defect because you can't see it.
Yes.
All you're doing is measuring the effect of it. So we call it a defect indication. So you take the defect indications and then you take the CIPS data and you say, well, is the pipeline protected in terms of cathodic protection criteria? So we've spoken previously about measuring potentials. And is the pipeline more negative than minus 850 millivolts with respect to copper sulfate half cells or not? At the same time, with the CIPS survey, you can switch the rectifiers or cycle the rectifiers is a better word to use to get what we call on and off data. And it is the off data that is more critical in terms of whether or not the system is protected. So sometimes you find that you'll have a defect, or a defect indication, I should say, and then the CIPS data tells you that this defect indication is protected, so you don't need to worry about it. In other times, you'll see that it's only protected when the CP system is on.
Right.
which shows you that it's a lower risk situation, provided the cathodic protection is running.
Yes.
The one that you really don't want is when you've got a DCVG indication and the CIPS data tells you that the pipeline is not protected at that point, then you've got a really high risk situation.
Yes.
And you can get perforation of a pipeline within months.
Sure.
In certain conditions, if that sort of combination of events happens.
Right.
And that you can tell by then processing this data back at the office. Also, you have the location of where this has occurred. So you can go back to that location and excavate it. And sometimes you find, well, actually, it wasn't the pipeline itself at all. It was a piece of scrap metal lying that got incorporated into the trench. And I think when we were talking about one of the previous survey techniques, we were talking about where we were looking for defects in wrapping. And the biggest defect I've ever found was a farm gate.
I remember, yes.
Yeah.
Now, because we're combining two surveys, what equipment do we typically use and how is the setup in the field?
Well, the CIPS DCVG survey requires more personnel than the single survey.
Makes sense.
So when you do a CIPS survey, you have a single operator. When you have a DCVG survey, you have a single operator. The CIPS DCVG requires two operators. And effectively, the one operator is measuring the potential, that's the CIPS survey. The other operator is actually just acting as a second set of electrodes. So he's trailing along, being dragged along by a 10-meter long cable, tethered so that you've got the constant distance between the two sets of electrodes. And it sounds like a very boring thing to just walk along, sticking electrodes in the ground, following the guy in front of you. But it's critically important that those electrodes are handled properly.
Yes.
So that you always have contact with the ground. One of the biggest challenges we have, because often maybe you would find a less experienced person being used in the second set of poles, and they walk as if they're skiing. So in skiing, your poles are in the air, and every now and then you stick a pole in the ground. With a survey, you've got to keep your poles in the ground.
Constant contact.
You must have always one pole in the ground. So you've got to put one down before you lift the other one up.
Right.
So that there's always these two poles. Right. So you have these two operators, but it does mean that you only have a single traverse of the pipeline. You don't have to walk the pipeline twice.
Correct.
So you walk it once with two people.
Now, is it possible to conduct this combined survey under conditions of stray currents?
Yes, it is. And that's actually one of the hidden benefits of this combined survey. A lot of standards and operators and so on have the misconception that you should not do CIPS surveys under stray current conditions because the stray current conditions actually cause the pipeline potential to change with time. You're measuring pipeline potential. So now you've got to differentiate between a change caused by stray currents and one caused by conditions in the pipeline environment. When you're doing the combined survey, you've got two sets of electrodes. And if both sets of electrodes, they're only 10 meters apart, the difference between the stray current effect here and 10 meters away is going to be negligible.
Yeah.
So if you find that both sets of electrodes change at the same time, it is a confirmation that the event that you're seeing or the indication that you're seeing is related to stray currents and not to pipeline condition.
Oh, interesting. Fantastic. Thank you. Now, how accurate are the results from a combined survey as opposed to doing them as two separate surveys?
Well, it's as accurate as the GPS technology that you've got built into your equipment. And these days, the equipment comes with sub-meter accuracy GPS engines. So you can go back precisely to the point where that measurement was taken.
Wow.
But you are then constrained by the accuracy of going back to a point which has not been indicated on the ground. If you think back to the DCVG survey, typically people would actually put a pin in the ground at the point of a DCVG epicenter.
Okay.
We can't do that with the combined CIPS DCVG because it is a post-processed survey. So sometimes it's necessary to go back with a conventional DCVG kit and relocate the point physically if you don't believe
Your GPS. Okay.
We've had some instances where a separate operator had done a survey. I can't remember now if it was a DCVG or PCM survey, and they had pegged various locations. And we were then doing a combined CIPS DCVG survey. And we had this GPS engine on the surveyor, and we'd get to a point, and I distinctly remember on one specific occasion saying, "Stop, the defect should be here." We stopped, we looked around, and it was about a meter away from where we had stopped.
Sure. Wow.
Yeah. So they're pretty accurate.
Yeah, sounds like it.
Certainly, they're accurate enough that irrespective, bearing in mind you cannot dig if your pipeline's a meter deep, you can't dig a hole less than maybe 2 or 3 meters in dimension. And within that hole, you're going to find
it.
You're going to find it if it's there.
What are some other common challenges you'd encounter when conducting these surveys, especially in difficult terrain or congested areas?
I think the biggest problem is fences, actually. So if you're going across a field and you've got 2 people doing this tethered survey, so they're moving along like this, and you come to a fence, you've got to get over the fence
and maintain that distance.
So sometimes what you find is that it's necessary for the trailing operator to move sideways in order to get through the fence and maintain this gradient measurement.
Okay.
So the CIPS DCVG is defined in the NACE specifications as a hybrid survey using longitudinal gradient. So that means that the gradient that you're measuring is the gradient along the length of the pipe.
Yeah.
A lateral gradient is if you
90 degrees.
90 degrees. So it's possible actually to do a lateral gradient survey with 2 people walking in parallel, one over the pipeline, one 10 meters to the side. That's really difficult unless you're in open fields and things like that. The other aspect of that is that you get a completely different DCVG signature when you're doing a lateral gradient to a longitudinal gradient. So you've got to know what's happening.
You've got to know the difference. Yeah. Would you be able to share an example where a combined CIPS DCVG survey helped uncover an unexpected or critical issue that might have otherwise gone unnoticed?
On one of the pipelines that we surveyed, where it had a very high electrical resistance coating, one of the polyethylene coatings, this pipeline had very high straight currents. And the potential in the straight current monitoring data logger was swinging all over the place. So naturally, the potential of the CIPS recorder was also going all over the place. And it was very, very difficult to tell whether these swings and changes were due to pipeline conditions or straight current conditions, because they were really moving by a value of several volts. And to try and pick up an indication of in the order of magnitude of hundreds of millivolts in amongst all these volts was difficult. The DCVG, on the other hand, is a much more sensitive situation because you're actually measuring millivolts difference between the front and back.
Right.
And we were able to pick up defect indications from the DCVG survey that were completely hidden in the CIPS survey because of the use of the combination survey.
Yeah. Sure. Now, how often should operators perform a combined CIPS DCVG survey as part of a comprehensive integrity management program?
Well, that really depends on the situation. If you have a new pipeline, it's an ideal survey to do at the conclusion of construction, because that gives you a baseline against which you can
measure in
future. Given that pipeline coatings don't degrade fast, you wouldn't expect defect indications to develop quickly. So from a coating integrity point of view, you'd probably look at doing it initially and then maybe in 5 years' time, and in 10 years' time, and so on, which kind of fits in with what is done with intelligent pigging. And that would be adequate. From a CIPS point of view, from the cathodic protection point of view, also, provided your cathodic protection system doesn't change or your environment doesn't change, once every 5 years is plenty.
Is adequate, right?
Yeah. But if there's a significant change, like maybe another pipeline gets constructed in the area, or the stray current interference pattern changes, or you've had a number of rectifiers that have gone haywire and you don't know if your system's working or not, then you would do that survey at a shorter period based on when and where the change happened.
Great, thank you. Now, wrapping things up, are there any recent technological advancements or innovations in CIPS DCVG techniques that pipeline engineers should be aware of?
I don't think so in terms of the actual surveys. The techniques are pretty standard. The advancements have been in the technology of the equipment that is used to record and process the data. And so the operators need to be skilled to be able to operate, because actually you're walking through the field with a miniature computer.
Right.
You've got to be able to operate that and know how to operate that, and to have a good understanding of what the data actually means, because the instrument is actually displaying the data on a screen as you're walking. And we had one instance where one of our guys came back from a survey and he said, there's something funny about this survey, because 2 consecutive readings were always different. So it measures and records an on potential, an off potential, an on potential, off potential, and so on. And normally the ratio is about 4:1.
Right.
Or maybe 2:1 or 3. In other words, you normally get more on readings than you get off readings. And he was telling me that the on readings, the first on reading would always be different to the subsequent on readings. And from his observation during the actual survey, we were able to determine that some of the AC mitigation equipment that was installed on the pipeline was affecting the accuracy of the readings.
Sure.
Yeah.
Before we started rolling, we started chatting a bit about the newer advancements in survey technology, including some electromagnetic imaging. Could you touch on that?
Yeah, so this is a new technique, and it's a groundbreaking technique, quite literally. Just as CIPS was a revolutionary technique 40 years ago, so now this electromagnetic imaging is starting to become practical. And it is an advanced form of the AC attenuation survey that we've spoken about, where instead of injecting a simple sinusoidal wave into the pipeline, you inject a complex waveform into it. And the detector then is able to map this complex waveform. And from that, by means of highly data-hungry processing, I mean, literally, we're now talking about recording and processing gigabytes of data.
Sure.
You are able to map an electromagnetic picture of the pipeline, which will pick up and determine potentials. It determines types of coating. It determines coating damage where the pipeline is polarized, and it doesn't actually show up as a defect from an electrical point of view, but it does show it up from an electrical resistance point of view. The kit is called EMIT, E-M-I-T, recently demonstrated at the CIPS conference in Europe, and it's very, very exciting. But it's going to have a place. I imagine that it is going to be a pretty expensive survey to undertake, but then intelligent pigging is also a very expensive survey to undertake. And we need to remember that pipelines are expensive pieces of infrastructure. You think of a pipe lying in the ground, it's just a pipe, you know. But if something goes wrong with that pipe,
it's incredibly expensive.
Consequences are expensive.
Yeah.
Fixing problems is expensive. So it is worthwhile spending some money to make sure that you don't have those problems.
Right. Neil, it's been incredibly informative to learn about the practical and technical aspects of a CIPS DCVG combined survey. We appreciate your time and your expertise, and we look forward to having you back in a new episode. And for those watching, I hope that this conversation has added depth to your understanding of specialized survey techniques. So don't forget to subscribe and turn on notifications so you don't miss any future episodes. Thank you.